Hello, my name is Ruby, and today I'm excited to share my presentation on the Grand Canyon National Park and its geologic history. I chose this park because of its importance, also because it is one that I have personally visited. In fact, this picture was taken on my trip there in 2017. Now to introduce the park. The Grand Canyon, located in Arizona, is one of the most iconic national parks and is the second most visited, according to staff in the article, These are the 10 most popular national parks. The park is so big that the only way it can be seen all at the same time is from space. It averages 10 miles wide and is 277 river miles long. It is also a UNESCO World Heritage Site. The canyon's geology is the main contributor to the park's beauty and uniqueness. Its layered features allow researchers to learn more about the geologic history of not only the location itself, but North America as a whole. Its unique structure makes it the perfect place to get a sense of geologic time for the region. Shown here is a labeled map of the park from the National Park Service. My first slide is about the anthropological history of the park. Indigenous people have lived in and around the Grand Canyon for thousands of years. We know this because many ancient artifacts such as pottery, tools, and even stone houses have been found there, as pictured above, according to National Park Service's People on the Landscape page. Today it is considered a sacred space by many tribes, with tribal villages located inside and around the canyon on nearby reservations. The lower image is a map of the tribe territories. The People of the Landscape NPS page states that European settlers began to explore the canyon in 1540, but did not settle there until the 1800s to search for gold and copper. Tourism to the canyon greatly increased after the railroad was finished in 1901, according to the book National Parks: The American Experience by Alfred Runte. As stated by People on the Landscape, President Benjamin Harrison first protected the canyon in 1983 as Grand Canyon Forest Reserve. Then Roosevelt made it a national monument in 1908. Shown in this image is Roosevelt touring the canyon. In 1919, it was officially made a national park under President Woodrow Wilson and was designated a World Heritage Site in 1979. Now to discuss the actual geology of the park and the rock itself. The Grand Canyon rock exhibits the law of superposition, which means that the oldest rock is at the bottom and the youngest is at the top. Grand Canyon's rocks are ordered into 3 sets, which are labeled on both of these images. The following data includes information gathered from the United States Geological Survey page, Geology of Grand Canyon National Park, and the National Park Service page telling time at Grand Canyon National Park. The oldest rock is referred to as the Vishnu Basement Rocks and/or the Vishnu Schist. They were once tens of miles deep during the formation of North America, when volcanic islands collided into the continental landmass 1,840 to 1,375 million years ago. The rock itself is 1.7 billion years old from the Proterozoic era. It is mostly schist and granite. Tectonic convergence caused this basement rock to be uplifted and exposed to the surface, where the following layers were able to build on top of it. The second layer of rock is referred to as the Grand Canyon supergroup. This layer is mostly composed of sandstone and mudstone with some igneous rock areas. These formed later than the basement rock in the late Proterozoic. It is associated with the Virginia supercontinent, forming between 729 and 1,255 million years ago. The rocks in this layer are sedimentary, deposited horizontally, and then were tilted due to plate tectonics. Later, the top layers of the sediment were eroded away, creating the Great Unconformity, which will be elaborated on in the next slide. This layer also contains evidence of single-celled organisms via fossils. The illustration here makes it really easy to see the difference between layers and the tilt. The third layer is called the layered Paleozoic rocks or Paleozoic strata. These layers are also sedimentary and mostly sandstone. It is much younger than the other layers, representing a time between 270 and 530 million years ago. The many marine fossils here and the sandstone tell us that the Colorado Plateau was below sea level and underwater in the Paleozoic era. The reason why the area today is uplifted is because of the laramide orogeny. The region has been eroding due to being uplifted and exposed for 70 million years. There are very few rocks here from the Mesozoic era because of this erosion. Speaking of erosion, this process can also create something else called an unconformity. Unconformities are very common in the Grand Canyon, especially in the 2 youngest sedimentary layers. Here's the definition from Geology and Ecology of National Parks by the United States Geological Survey. This is when there is a gap in the geologic record due to rock/sediment eroding away and time elapsing before a new deposition occurs. The diagram on the left from the National Park Service page, Numeric Ages of Grand Canyon Rocks, shows where the Great Unconformity is located in red. Now to discuss the canyon itself. Tectonics caused more uplift and a slight tilt 6 million years ago, making it so that water was able to start to flow downward and erode and cut through the rock. This water went on to become the Colorado River, as pictured above from 2 different angles. It took millions of years to carve the current canyon and had fluctuations in its speed, intensity, and width throughout. We can see that the canyon formed much more recently than the deposition of the rock layers. Next, to talk about fossils. The fossils at the park can tell us a lot. Since they are mostly marine, this, along with the composition of the rock, leads researchers to believe that this area, and in fact the entire Colorado Plateau, was all underwater in the Paleozoic era. According to the United States Geological Survey's Geology of Grand Canyon National Park page, some of the most common fossils found in the Paleozoic strata of the Grand Canyon are 1. Trilobites, pictured here, which lived in shallow marine environments, 2. Trace fossils that are the tracks and burrows of marine organisms, and 3. Brachiopods, pictured on the left, which are left behind shells of creatures common in the Paleozoic. A quote about the supergroup layer from Geology of Grand Canyon National Park states, "The composition and presence of stromatolites indicates that this area was previously a very shallow sea." This fossil was shown in the middle picture. Now to look toward the future of the park. And when doing this, the foremost topic on our minds is climate change. Climate change, which leads to more extreme weather events, has affected conditions for many parks. They are seeing warming temperatures and less rainfall. According to the National Park Service page, Grand Canyon National Park Action Plan, these things will primarily affect the vegetation communities and animal habitats as pictured above, changing the ecosystems of the park. Heavier storms, also pictured, may negatively affect the canyon with unexpected flooding. National Park Service's action plan states that the goals of the park include efforts to reduce greenhouse gas emissions, promote energy efficiency and conservation, and increase education and community outreach about climate change. This is a good note to conclude the presentation on because it reminds us not only the importance of the parks and how they connect us to the past, but how our stewardship of them can keep them available to all in the future as well. Thank you.